Hi, good morning to all my students. In connection with yesterday video, that is video 1 on probability, I am discussing today some phrases which are frequently used in probability. Okay. If a coin is tossed, what will be the two chances? Head or tail? They are having same chance to turn up? Yes, no doubt. So, head and tail are equally likely events. Equally likely events. Today, you are going to learn at first equally likely. It is the phrase most frequently used in probability. What is equally likely? Just in the easiest way I told. Same chance is there to turn up tail or to turn up head. If tail comes, it is an event. If head turns up, another event. These two events are equally likely. For example, if you want to roll one die, 1, 2, 3, 4, 5, 6. Okay, like this. How many will be? 6 will be. 1, okay, 2, 3, 4, 5, down 6. 6 faces are there. One face will turn up. That we don't know. That is why that experiment is called random experiment. Yesterday you learned random experiment and sample space. Yesterday you learned random experiment and sample space. Today you are going to learn, firstly you are going to learn equally likely. Equally likely. Equally likely. Equally likely means the same way. Likely means a chance. Equally likely, the same chance will be there for turning up 1, 2, or 3, or 4, or 5, or 6 while rolling a die. So, every event while rolling a die, every event turning up 1 or turning up 6 or turning up 5, those are the events, no? Turning up after rolling. So, those events are called equally likely events. Equally likely means equal chance may be turning up. Equal chance may be there to turn up. Okay, so that is called equally likely. Likely means chance. It is not likely means in English, I am liking you, I am not liking you, I am liking you. That meaning is not there. Likely means in English language, another meaning is, of course, a chance or probable. I will likely come to your house today evening. It means there is no guarantee to come to your house. I am not giving any surety to come to your house. Therefore, I am using this sentence. I am likely coming to your house in the evening. Likely means that one. Chance may be there. This is with same meaning we are having equally likely. Equally likely means the same chance will be there for turning up 2, 1, 3, up to 6 while rolling a die, or while throwing a die. Okay, so you learned at first, today equally likely. In this, which is not equally likely, also I will just mention you to make you understand better. How? You see, if a pair of dice is thrown, pair of dice is thrown, occurrence of the sum 6, 1, 5, 2, 4, 3, 3. Okay, 4, 2, 5, 1. Okay, like this, total, what is the occurrence of the sum is 6, total 6. If you roll 2 dice, first die will give you 5, second die will give you 1, will turn up 1, total 6, like that, 2, 4, 4, 2, 3, 3, like that, no. Some events will come, that is occurrence of sum 6. Sum, S-U-M, sum means total 6. And occurrence of the sum 3, first 1, 2, or 2, 1. Okay, is there any case to become 3? The sum 3 to become sum 3? 2, 1 or 1, 2? Is there any case? You are not finding any case. So, can we say equally likely? No, because there is no maintenance of same chance. There is no maintenance with the same chance. The chances may be more. For the sum 6, 2, 4, 3, 3, 4, 2, 5, 1 will be like that. For the sum 3, 1, 2, 2, 1, this is different. This is different because in one die 6 numbers only will be there, 6 faces. And the second die also 6 faces will be there. If we throw 2 dice, then 2 numbers will be coming. How it will be? Sum 3 cases will be 1 plus 2 or 2 plus 1. Is there any possibility? No possibility here. Therefore, what can we say? There is no equally likeliness. There is no the similar way of chance. Same way of chance of getting sum 6 for getting sum 3. It has no same way of chance. Therefore, these events are not equally likely events. These events are not equally likely events. Okay, let us go out of this equally likely to another phrase which is frequently used in probability. Because all these phrases you must understand very clearly. In the questions, these phrases will be frequently used. Then you will be confused. What is the meaning of this? How to do this sum? So it is very important. Next. Mutually exclusive events. Mutually exclusive events. Mutually exclusive. What is exclusive? Mutually exclusive events means, I will tell you one thing. In social aspect, your family, somebody came and invited you for the marriage dinner. Okay. And specifically he told only one person must come. Only one person is invited from your family, suppose. So here, if your father goes, your mother is excluded. The going of your father, the attending the dinner of your father, the attending of your father to dinner is excluding attending of your mother to dinner. Attending of your father to dinner is excluding attending of one son, okay, to the dinner. If son goes, the attendance of the son to the dinner excludes the attendance of the father to the dinner. So because one person is invited from your family to attend dinner, anybody of father and mother and one son will be there. 3 people are there. Out of these people, if anybody goes, the going to the dinner will automatically exclude the others. That is called mutually. The son excludes father's attendance to dinner. The father excludes the son's attendance to dinner. Or else, father attendance to dinner excludes mother's attendance to dinner, and vice versa. Therefore, it is used the word mutually. So, mutually exclusive events. I have given this example. Of course, there are so many sums from social affairs in probability. So many sums, very naturally. In the questions of probability, not only social affairs, all affairs in maths, affairs in economics, affairs in physics, affairs in chemistry, in all whatnot, in all sorts of sciences, all the affairs of the sciences will be attending or may be attending in the, may be appearing, may be attending in the questionnaire of probability. Therefore, I told this. You see here, in the experiment of throwing a die, same thing I told. In the experiment of throwing a die, the event, supposed to say E1, capital E1, occurrence of even number. So if you throw a die, even number may turn up, because equally likely, may turn up. So occurrence of even number, say E1, capital E1, event 1. Occurrence of odd number, say event 2. So these two events are mutually exclusive. Because if occurrence of even number excludes occurrence of odd number, and vice versa. Just I told, father and son attending to the dinner. Similar case. So here, occurrence of even number excludes occurrence of odd number Or else odd number, occurrence of odd number excludes occurrence of even number. This situation and these two events are called mutually exclusive events. Mutually exclusive events. Very clearly understood. Today, you learn the very second one is, first one is equally likely, the second one is mutually exclusive. Okay, here, which one is not mutually exclusive also you have to learn. Let us take one illustration. In the experiment of throwing a pair of dice, two dice. Event 1, suppose event 1, a sum 7. 7 must come. 1 6 or 6 1 or 2 5 or 5 2 like that. 4 3 or 3 4 like that, 7. A sum 7 is event 1. Sum 6 event 2. Sum 5 event 3. A sum greater than or equal to 7. A sum greater than or equal to 7 means 6 6, 12. 6 5, 11. Like that. It may be no sum. A sum greater than or equal to 7. That is E4. What is E1? E1. Event 1. E1 a sum 7. Event 2 a sum 6. Event 3 a sum 5. Event 4 a sum greater than or equal to 7. What are E1, E2, E3? Definitely mutually exclusive. Definitely mutually exclusive. A sum 7 naturally excludes a sum 6. How it is possible? 4 3 will be there, 3 4 will be there, for 6 3 3 will be there. So it is naturally excludes. So mutually excludes and vice versa. So a sum 6 excludes a sum 7 or a sum 7 excludes sum 6. Therefore mutually exclusive. So a sum 7, E1, E2, E3, a sum 5. Also, these are all mutually exclusive events. No doubt. Now clearly understood when 2 dice comes, when 2 dice we apply in throwing. So sum 7, sum 6, a sum 5, event 1, event 2, event 3 are all mutually exclusive. E4 will be there. E4. What is E4? A sum greater than or equal to 7. E1 is there. A sum 7. A sum 7 is there. Here a sum greater than or equal to 7 is there. Are mutually exclusive? No. E1 and E4 are not mutually exclusive. Are not mutually exclusive. So here a sum 7 even, it will not, it is not excluding E4. What is E4? A sum greater than or equal to 7. Therefore, both are not mutually excluding each other. Therefore, E1 and E4 are not mutually exclusive. In all cases, I am telling that what is that? Negation and positiveness. Negatively, I am telling that which in case when the events are not firstly what I told, are not equally likely. Now, are not mutually exclusive. Here, not mutually exclusive what? E1 is sum 7, E4 is sum greater than or equal to 7. E1 and E4 are not mutually exclusive. This any one of these two, either of these two is excluding the other. It's not excluding. So neither of these two is excluding the other. Neither. Next. Here, in the experiment of rolling a die, a simple example, rolling a die. The events, E1, occurrence of even number, E1. E2, occurrence of prime number, E3, occurrence of one, only one. Occurrence of one. How it is, let us see. Here, E1, E2, E3. E3 is there, occurrence of one is excluding. Is it excluding? What is occurrence of one? E3. E3 is excluding E1. What is E1? Occurrence of even number. No. Even number is 2, 4, 6. Dino 2, 4, 6. 2, 4, 6 even number. Occurrence of 1 coming up, how it excludes? No. Next. Both are not mutually exclusive. Very clear. And E2, I have told you, what is that? Prime number, occurrence of prime number. Prime number you learned in, I think in LKG or UKG, prime number. 2 prime number, 3 prime number, 5 prime number. 5 ones 5, 3 ones 3, 2 ones 2. There are no other factors. 1 you don't take. Here 2, 3, 5 are the prime numbers. 2, 3, 5 are excluding occurrence of even number. Excluding occurrence of even number. Even numbers 2, 4, 6. This is not excluding that. If you take this, you are not excluding it. So here, E1 occurrence of even number, E2 occurrence of prime number, E3 occurrence of 1. Not mutually exclusive. Not mutually exclusive events. These are the things today you learned. Mutually exclusive, and equally likely, having same chance. Okay. And now, algebra of events. Algebra of events. Algebra of events. Algebra of events. Here, complementary, you have learned sets when 9th class or 8th class. Complementary, A dash. A dash equals to S minus A. What is S? Sample space or universal set. Yesterday I told. So S minus A equals to A dash. Okay. What is this? Complementary event. Complementary event. What is complementary event? Please listen carefully. Complementary event is denoted by A dash. A dash equals to S minus A. S is universal set. You have to subtract or you have to remove the set A. That S minus A is nothing but A dash. That can be said like this. Not A to the event A. Not A. While you are writing, not A should be in inverted commas. Not A should be in inverted commas. Not A to the event A. Here, this is another version of expression. Another version of expression. Not A to the event A. It means complementary event. In the second point, the event A or B, I am discussing with the sets. Because in probability, sets operations will be there more. That is why before this I have dealt with sets and relations. Most of the people, they are poor. Most of the students are poor in the subject sets, relations, combinatorics and probability. Because this is a science of logic. Science of logic. Okay. Science of logic. Numerically treated. Logic numerically treated. So this is different. Interesting also. All affairs will be coming inside of the probability. Love affairs will come. Liking affairs will be coming. And social affairs will be coming, political affairs will be coming, economics will be coming, monetary affairs will be coming, all affairs will be there. So, on one of these, any affair, the question can be prepared, can be made or can be cooked. Question can be cooked and may be given in the question paper. So here, the event A or B, or A or B, then what to do? You have to write it as A union B. A or B, set A or set B. We have to write it as A union B. The event A and B, you have to write it as A intersection B. A and B means A intersection B. A or B means A union B. Next, the event A but not B. The event A but not B. A minus B. The event A but not B. A minus B. That is, A minus B can be said as A minus A intersection B. A minus A intersection B. Okay. A intersection B means the common part, the common portion of sets A and B. That is A intersection B. From A, if you deduct, what you will get? A minus B will get. So A minus B means the event A but not B. The event A but not B is nothing but A minus B. Implies A minus B equals to A minus A intersection B. Remember this very carefully. Next, another term has come. Only one word, one term, exhaustive. Exhaustive means, everybody knows in English language. What is exhaustive? Complete. Here in police department they will say exhaustive research in science department. Exhaustive investigation in police department. CIDs or CBI, exhaustive investigation. So, exhaustive means every pinpoint is observed. No even pinpoint is left over. That is called exhaustive research, exhaustive investigation. Like that. Same thing here also. You observe exhaustive. It is a technical word. It is a term frequently used in probability. Exhaustive events. Exhaustive events. A equals to set of 1, 2, 3. Just a small kid can understand. I am giving set A equals to set of flower bracket you will open 1, 2, 3. Okay, simple. And B is equals to set B is equals to set of 3, 4. Set of 3, 4. Capital C. Set C equals to set of 5, 6. First set A 1, 2, 3 set. Set B 3, 4 set. There is 3 common in A and B. Okay. In C 5, 6 set. There is no common number. Anyway. What is A union B union C? It is nothing but S, capital S, sample space. Then, when you take union, what you are taking here? S equals to set of 1, 2, 3, 4, 5, 6. That's all you will take. This set you know very well while throwing a die, while rolling a die. The face with number, either 2 or 1 or 3, turning up. So 1 to 6. What is sample space? Set of 1, 2, 3, 4, 5, 6. What are the separately given? 3 sets are given. These 3 sets, okay. These 3 sets, let us take 3 events. The event, first event is A, set of 1, 2, 3. Second event is 3, 4, and set of 3, 4. And third event is set of 5, 6. These 3 are called exhaustive events. Are called exhaustive events. Exhaustive means without leaving any smallest part, considering all, exhaustive, entirely, completely, like that. So here, exhaustive events you have understood. I am giving you another one. In the experiment of rolling a die, S equals to, capital S equals to 1, 2, 3, 4, 5, 6. Okay. Even odd numbers appears. That is one event. E2, even numbers appears. It means even excludes E2. Even, event 1 excludes E2. And vice versa. So, even intersection E2 equals to 5. E1 intersection E2 equals to null set, because E1 is set of odd numbers. E2 set of even numbers. Then what is the intersection? No intersection. So it is 5, null set. So they are called, E1 and E2 are called disjoint sets. To tell this term, I have told this illustration. Disjoint sets only when E1 intersection E2 equals to 5. Okay. Now let us come to the approaches. Different approaches are there to probability. One approach is axiomatic approach. Yesterday I told. The second approach is, not second, another approach is mathematical or classical approach. Both approaches are significant. They are playing important role. That is called significant. Here, axiomatic approach. S be the sample space of a random experiment. I told random experiment. The probability P is a real valued function whose domain is the power set of S. It is very important for competitive exam. S be the sample space of a random experiment. S be the sample space of a random experiment. You have to use like this terminology. We should not speak as we wish. We should speak according to the terminology introduced by great mathematicians. Very earlier, some hundreds years back. That only we have to speak. Here, again I am telling, S be the sample space of a random experiment. The probability P, capital P, is real valued function. Yesterday as I told, in axiomatic approach, real valued function is taken for probability P, capital P. Capital P is considered as a real valued function. If there is function, there are two things. One is domain, another is range. For every function, we have to discuss about these two only. Domain and range. Without domain and range, function is not defined, no. So, we have to tell what is domain of this real valued function probability here. Power set of S. That is the domain of real valued function probability. Domain of real valued function probability. Its domain is, again I am telling, power set of S, power set of sample space. Power set. I think you learned power set in, I think it is in 8th class or 9th class in sets and relations, in sets introduction. In the introduction of sets, you have learned power set of power set. What is power set? Just I am reminding you what is it. Just I am reminding you, I am remembering you. Please recollect once. Recollect once. If one set is there, 1, 2, 3, I am giving one example. What is the power set of this set of 1, 2, 3? All subsets which come to this given set, all subsets which come to this given set, if you write all subsets as the elements of the new set, all subsets, if you write all subsets as the elements in a new set, that new set is nothing but the power set of the first set, the given set, the taken set. That's all. For example, 1, 2, I have told 1, 2, 3 also I told. Okay. 1, 2, 3. Set of 1, 2, 3. To every set, null set is the subset. So, now set of all subsets must be kept in the places of elements and you have to make a new set. No, that is called power set of the taken set. No, therefore, null set is subset of every set. So, first in the power set making, in the making of power set, first we write null set, comma, 1, singleton set 1, singleton set 2, singleton set 3, next set 1, 2, set 1, 3, set 2, 3, next 1, 2, 3, like this, whatever subsets will be coming, all the subsets you have to pick up or choose, you have to write in one set form kept as elements. Okay, it's over because I have just reminded I don't like to waste time for the for what is this? For 8th class subject. For 8th class subject. I don't like to waste. Here, power set of S. What is the domain of the probability real valued function? Domain of the real valued probability function is the power set of sample space. Power set of sample space. Okay. Next, what is the range? Firstly, I told yesterday only. Range is closed interval 0, 1. Because impossible probability is 0. Sure. Here, what is the domain? What is the domain of the real valued probability function is the power set of sample space. What is the range? of the real valued function probability closed interval 0, comma 1. Why 0 minimum? Because that is impossible probability. Impossible probability. 1. It is the probability for sure event. That is the maximum. So, therefore, the range of the real valued probability function is closed interval 0, 1. Okay. These axioms will be discussed tomorrow. Okay? These axioms will be discussed tomorrow. Bye. But one thing, don't forget, every time I have to tell, I think, don't forget what? Share and subscribe. Like, share, subscribe all the videos so that the updated videos will be coming to you. And pass on this to your friends and friend world. Friend world. So many friends you are having. Help them. They will also listen my class. They will learn the subject. They will flourish. They will study well. It is also plus point, They will also appreciate, They will also praise, Okay? Doing good thing is always good for all. Thank you.